Well, thank you all for coming. This is BlockChain an Introduction. And my name is Greg Doud. I work for Max Technical Training. I'm actually a boot camp instructor, and I teach software development for a living. We do it in 11 weeks in our full-time boot camp. So we have a table down there, which probably won't be open that much longer when we're all done here. But if anybody has any interest or have friends that might have interest, we'd be glad to talk to you about it if you want. Blockchain is, this is an intro to blockchain, so it's really fairly high level. And one of the things we're going to get focused on is what makes blockchain unique. So if any of you are interested in actually developing applications using blockchain, take this as core concepts that will help you to write better applications, knowing what blockchain does. And this is one of the issues that the people in the blockchain community are struggling with right now, is what kind of applications are great to use blockchain for. And I'm going to give you an example a little bit right off the beginning of this presentation. I will answer questions at the end. I'll do everything possible to make sure that we can answer some questions for you before we break. So, all right. So, and like all good presentations, we want to start with an agenda and tell you a little bit about it. So, the first thing we're going to do is, would you buy this watch? Now, you haven't seen the watch yet, so you can't make a decision. But you're going to see it very shortly here, and then I'll need to get some feedback from you about whether you would buy this watch. But the key aspects then of blockchain that we're going to talk about here are the core technologies that make the blockchain what it is. And we're going to go through each one of those at a level that says what it is and why it's important and how it fits together to make blockchain what it is. And those things are public-private keys, hashing, something called mining the blocks, which almost everybody has heard something about, and the chain itself. And we'll talk about all of these, but public-private keys are not a new technology. They've been around a while. Some of you may be using public private key technologies in your jobs, in your applications, and so on. But it's one of the very preferred ways to be doing security right now in terms of encryption, because you never have to pass your secret around to anybody else. And that's one of the things that breaks a lot of encryption and security things, is that people somehow let somebody else see their password. Okay, so, and I'll talk more about what public-private keys are. Hashing, if you've been in programming a while, you'll know hashing is pretty prominent in a lot of languages. And really, you can think of hashing as just a technology that is a way to look at two different things, two objects, and say, are they the same thing or not? Are they identical? And if they're identical, they'll have hash values, and I'll explain what that is in a little bit, that are the same. If the hash values are different, then the objects are not the same. It's really just that simple. And we do it all the time in programming. I'll talk a little bit about my background and so on here. So the mining of the blocks. Mining Bitcoin, they talk about it. I don't know if you've heard that. That's a little bit of a misnomer to what's actually happening here. But I'm going to tell you what that's all about. And it's really a very key aspect of why Bitcoin is what it is and how it purports to do things that the existing technology can't do. And not that it was real hard or difficult. It was someone with a creative mind thinking through the problem and say, what do I know? What can I do today to solve this particular problem? And I'll describe that problem, and you say, it sounds so simple, but it's the fact you put it together. There's two pieces to it, and I'll talk through those. Finally, the chain itself. It's called blockchain. You've heard there are blocks probably in that. They're chained together. What does that mean? And how is it actually done? And how does all that come together to accomplish what's been termed in the blockchain technology, this new thing that allows you to do things that keeping databases secret doesn't do, or encrypting everything in the world. That doesn't work and all that. How does blockchain do those things that the other technology that doesn't seem to do, or at least has holes in it? Okay. And I said, I definitely will work to make sure you have some time to answer some questions and so on. So me, I have been in the software business since I was in high school, which was a long time ago. I did my first professional job in software development in the early 80s. I've been doing it ever since. I still love it as much now as I ever did and enjoy doing it. And the only thing I found I enjoy better as a profession is actually teaching. Teaching people who want to learn this profession is a very rewarding experience for me. And those who want to make a career change or something like that, we're glad we can be able to do something for them in that regard. They're very motivated to find their new careers. I am a boot camp instructor at Max. I teach the boot camps. I teach the .NET, which is where all my professional experience has been, starting from the beta 1 of the Microsoft.NET, which came out in around the year early 2000. And I've been using it ever since, and it's a great technology. It keeps evolving, but we also have a Java boot camp that is available, and I teach some of that too. It's a full stack type program. I love creating applications with that architecture, and it's just about as enjoyable teaching others to do it too. So I'll answer any questions about that if anybody's interested. And I'm a self-described geek, okay? I really like technology, somewhat for technology's sake. When I was in college, right here at the University of Cincinnati, but it was a few years ago, all my free electives were in computer programming classes or computer science classes. I did mainframe assembler classes. I did operating system classes. Although my degree was in business, I had 2 years of accounting, a year of finance, and 2 quarters of COBOL was my programming requirement. Right? For those who know what COBOL is. It was a while ago. If you want to connect with me, here's my personal email address and my LinkedIn profile. I will connect with anybody on LinkedIn. All I'd ask that you do is mention that you came to the blockchain presentation. And on question, I will connect with you on LinkedIn. I have a little over 1,000 people I'm connected with right now. So, and if I could help you in any way, I'd be happy to do that. Okay? Okay, ready for the question? The question is, will you buy this watch from me? Now, this is the one I'm wearing, but I have this watch, you could assume, and I want to know, any of you buy this watch for me? Now, I will tell you, if it's any reason to be considered, is the list price on this Rolex watch with all those real diamonds is about $110,000. Now, assuming you actually have those type of funds available, I know you may not have it with you, but you need a watch like that. Who's going to run around with $110,000 on their wrist? Okay, would you buy that watch from me if I held that up to you and said, here it is, we buy this watch? I actually inherited this watch from my grandfather. He just handed it down to me. I need money to pay off my student loans, and so that's why I'm willing to sell it. And I will sell that watch for $80,000. Okay? Who's in? Nobody? Come on, guys. You gotta like watches, right? Even if you're not wearing one now, if you had that one, you wouldn't wear that one either, would you? Because you'd put it in the bank, right? But nobody would buy that watch. Why would you not buy that watch from me? Yes, sir. If you could sell it, but you'd buy it from me? If I had it right here and you had the money, you'd buy it right now. If I can make more money, yes. Okay. We got one. Anybody else? Nobody else. For those who will not do that, I'm a very trustworthy individual. I hope it's not because I don't look trustworthy. Does that have anything to do with why you might be hesitant to buy? Not even a little. I'm glad. All right. What concerns would you have then? Why wouldn't you buy it? Yes. What's that again?
When you buy a
Okay, yeah, you could go to the store, but you pay $110,000 for it. I said, mine's a bargain at 80. Yes.
I don't have $80,000 for that watch.
That's, you really can't get bogged down in details about this, okay? All right. Yes. Depreciated value. What do you think the value is? Whatever I said it was? So you really trust me, don't you?
I wouldn't be able to be certain about its authenticity.
Ah. Anybody else feel the same way? Would you be absolutely certain that that's a true Rolex watch and those are actual diamonds? I got some real estate you can buy down in Florida in the bog or something like that. Yeah, I wouldn't take someone's word for that. I'd say, we're going to a jewelry store right now and I want a jeweler to tell me that's real. It could be a knockoff, right? I wouldn't trust me as trustworthy as I know that I am. Right? What else? Let's say we make that trip to the jewelry store. And we walk in, the jeweler takes it and looks at it, takes a little spyglass and says, it's legit. It's a real Rolex. Those are real diamonds. The real list price, $110,000. So now you have no more issues, right? If you had the money, you'd buy, right? No? Why not?
I don't know, because you pulled it off your wrist and it didn't come from like the source. I don't know. That's too much money to risk any kind of anything going.
Who said it might be stolen?
Maybe the jeweler is your brother.
Maybe.
It's not physically appealing.
Oh. Okay, well, I wouldn't be able to do anything about that, but it would be very legitimate for you to say, how do I know you're the real owner, that I really own this watch? Maybe I got that real Rolex watch under nefarious circumstances. Wouldn't you be concerned? Because if you give me the money and it turns out to be stolen, they're going to take it back from you and you're out. I may be in jail, but you're out the money. So there's two things at least that you'd be concerned about. One, is it real? And two, do I really own it? You would have to get those two questions answered. Don't you agree? Okay. And those would be absolutely legitimate questions. Now I said, and of course it's a made up because I don't have it yet. I'm working on it, but I inherited it, so there's no paper trail. It'd be a legitimate story. I said, I don't have a paper. I inherited it from my grandfather. So I can't show you a paper trail from all the way back. So you would deal with this any time you have an object like this that you want to know, one, is it real? And two, does somebody who's trying to sell it really own it? At a minimum. You look at other things in this world and there'd be lots of other questions you have to ask. Like if you're buying coffee from some in big sacks, you might want to know, is it free rate? Is it, not harvested under duress, and whatever else you want to know, but you don't get that. You only get the information from like the person you're dealing with. There's no way, no normal way for you to go back and see how it flowed through the entire industry. What if you could go back and look through the internet, and there's this magical app that says, okay, that watch with its serial number, of course, and look back at everybody who had that and how that person got it, all the way back to the Rolex company created this watch on this date and put it on their shelves to be bought. If you could track that all the way back, would you be more confident to buy it if it came all the way from me? And I was in that last part of that chain, right? That's what one of the things BlockChain does. Exactly that. And we'll go through that, an example like that. So when you get that, you write me a check. Now, the check is a promise to pay. Yep. Okay, so now you're doubting my integrity. You give me a check for the $80,000, and I say, wait a minute, how do I know you really have $80,000? Well, I'll try it. Say, but I'm not giving you the watch till it clears, right? And what clearing is, I take your check, I give it to my bank, who looks at, and then sends it to your bank, and your bank looks at your account and says, does this person have the money? And if you do, they'll debit your account, send that money over to my bank, we'll put it in my account. But not till that's all done do you get the watch. Right? Do banks get hacked? Yes, they do. Anybody caught their bank in an error? Ever? You've never caught your bank in an error? Well, let me tell you, banks make errors. And if you don't challenge them, they could find it on their own. But they do make errors. And I went through it a multiple of times, not big errors, but errors. And I had to go prove to them that they were wrong and I was right. That was not a fun experience, but you have to do that because they assume their ledger is correct and you're wrong. It was not fun at all. Okay, so we've got this technology, blockchain, and if you heard anything about it, you might have heard some of these terms being thrown around, like it's a transaction, it's a ledger, it's distributed. Heard those terms so far? And then you hear the terms not so in general use, like immutable. You know, it's us programmers, and I assume for those of you who are programmers, you've done this. You know what immutable means. It means you can't really change it. Once it's created, you can't change it. It's distributed. It doesn't exist in one place. It exists in many different places. And there are blocks involved. And you talk about the mining process, and what the heck is that supposed to be? Wikipedia defines a blockchain like this. It says, a distributed public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks. Sounds like a mouthful. But the claims are pretty significant. It's in the public, number one, which means it's multiple places, number two. And then they say that it cannot be altered retroactively, meaning the stuff that's already in the blockchain cannot be altered, but it's in the public and it's distributed. How many are software developers in here? Okay, the vast majority. All right. Does that make sense to you that you could put something in the public and say it's all over the place, lots of people have it, and it can't be altered after you put it out there? And I will tell you that the blockchain is text. It's just text, right? You say, I don't get it, all right? The distributed part, okay? When I first looked at blockchain, I said distributed, okay, I kind of get that, I know what that's about. But this thing about putting it into public and then not being able to change it, I just don't get that at all. And another thing that I didn't like about it when I first heard about blockchain was, do you want your financial transactions to be out in the public in text? I didn't. I said, no, I'm not doing that. You hear all of the hacking episodes and so on, and what nefarious individuals do with some personal data, much less putting your entire set of financial transactions out in the public. Really? I'd rather buy the watch and find out it's a fake. I'd probably lose less money. I mean, you hear people get wiped out with that. So I had lots of concerns when I first heard about blockchain. And I heard about it through Bitcoin. But I'll tell you that blockchain is the enabling technology for Bitcoin and the other cryptocurrencies. Were it not for blockchain, we wouldn't be hearing about Bitcoin and stuff like that. You couldn't do a Bitcoin without a blockchain, okay? All right, so we're going to talk about what these are, and I hope to belie any fears you have about whether this is really a technology worth exploring, worth writing apps against, and so on. I believe strongly in blockchain. I think there are lots of uses. I think right now the computing world is looking for ways to leverage this technology. The task now is dreaming up the ideas that what we can use blockchain to do things better than we do them today. And the more they do that, just like applications in general today, the more things we accomplish, the more they're going to dream up new things to do with it. So I think it's going to become a real foundational part of the software development world, regardless of what technologies we're talking about. You're going to be able to do it in probably every technology, right? It's not that, it's the what it is. It's sort of like when SQL databases came out. If you're old enough like me to remember back when SQL databases came out, okay? Okay, the first thing and the most important thing to me had to do with if I'm going to put my transactions out on the web, how are you going to keep them private? How does that work? It says, I don't want my account numbers out there. I don't want social security numbers out there. I don't want my name out there. I don't want any of my relatives' names, nothing. How are you going to put my transactions out on a publicly available piece of software or data, really, and keep me private? Well, that's through this public-private key. All right? And the public-private key, as I said, it's a great technology. And if you're concerned about security, and you should be, you should use public-private keys wherever possible. They will make you more secure. And they're very hard to remember. There are two pieces, which we'll talk about those. This is a sample public key, and I'll talk about public versus private. Public keys are meant to be given to other people. So if you wanted to send me a message, interact with me privately and securely, and that was my public key, which it's not, I would give you that. I'd post it on my Facebook page, my LinkedIn page, on the internet. Anybody can have it. If you want to interact with me, there's my public key. Okay? That doesn't sound right so far. Okay, but public-private key, there's two keys involved in this. The public key is one, freely available to anybody. Give it to everybody. But there's another piece of it. There's a private key. And the public and private keys are inexorably locked together. There's only one private key for your public key. You got to keep the private key secure and private. Never give it to anybody else. There is no reason to give it to anybody else. You don't have to send it to anybody. Keep it to yourself no matter what. And it's a lot bigger than that public key is. And it's no easier to remember. It's all done programmatically. But in essence, what you're going to have is we got some plain text. It could be anything. It could be a transaction. It could be a message. It could be a database, whatever. You take that plain text, whatever it is that you want to send to me, and you use my public key to encrypt that data. Now, the only person in the world who can decrypt that data is me, and only with my private key. That's pretty cool stuff. Just imagine, the only person in the world that could decrypt that data. You could all be sending me the message. All encrypted with my public key, and I'm the only one in the world that can decrypt it. That's security. That's much better security than we got. Then if I have to give you my password so you can encrypt the data, and then I can encrypt it with the same password. Nah, we don't want to do that. Public-private key. So what happens in the blockchain, when transactions are put on the blockchain, they are encrypted. And if someone is sending me Bitcoin, some money, you're sending me the watch, whatever, you encrypt it with my public key. That's what shows up on the blockchain, my public key, encrypted data with my public key. So if it's meant for me, I use my private key and I can accept whatever you send, but nobody else can. And that public key doesn't identify me at all. In concept, it looks like everybody else's public key. It's just a string of characters and it all looks like garbage. Okay, so what I wanted to show here, flip to here. Let's see what I have to do to get this to display. Here we go. And make this a little bigger. See, when you present a lot, you know things like you got to make things bigger than it looks. So I didn't create this page. I found this on the internet, but it shows well how public-private key works. So what I'm going to do here is I'm going to find my cursor. There we go. And I'm going to click this Generate Keys. Now, these two numbers, 61 and 195, are a public-private key. Now, they're nothing close to what real public-private keys are. They're very simple. It's for just illustration purposes. But the way it works is the same. So those have to stay together. So I have a message here. Hello, DevFest, from Greg Doud. Okay? That's my message. To you be sending me this message, let's say that, and you have my public key, which is 61. So in here, I take this and I'll put, you would be doing this, you put 61 and say, encode that message. And there you go. There's the message. Looks great. I don't know how many characters it is, but it's a bunch. Okay, so you can send that whichever way you want, embed it in an email, send it through text messaging, whatever. And so now I get the message, and or someone else intercepts it, let's say. Some nefarious person intercepts that message. And they don't know my private key, thankfully. So since my public key is 61, my private key is 195, let's say they guess and they think it's 222. I don't know how they figure that out, and they take my message and decode it, and there's what they get. Not even a sniff. Anything other than my private key, it's going to get garbage. But only when I put in the 195 and decode, then we get the message back. You can actually use either key. Right? But you will see that the public key in real life is much smaller than the private key. So what you would do is that you would always give others your public key, and then you keep your private key.
Do you use the public key as the decryption key?
No, you would use my public key if I sent you a message. Because if I sent you all a message, you would still have my public key, but I would encrypt my message with my private key, and then you could all decrypt it. But only if you have my public key. They work together. Encrypt with one and decrypt with the other. The thing is, everybody's got the public key. I'm the only one that's got the private key. So if I send you that message, you know it comes from me. Because if you use my public key to decrypt it, if it's anything else, you'll get garbage. Only if you use my key and you decrypt the message, you know it's from me. Make sense? Yes, sir.
If you use your private key to send something that identifies from you, but since your public key is public, you presumably wouldn't want to send anything important in encrypting with the private key.
If I want to send you a message and you want to make sure that you know it's from me and not somebody impersonating me, I would encrypt with my private key. Then you take my public key and decrypt it. And if it's anybody else, they wouldn't have my private key, so your decryption wouldn't work. Only if it came from me. So you would know that message came from me if my public key decrypted it. Does that answer your question?
Sorry, not entirely. So maybe I'm not grasping the concept fully, but sending something with a private key, while it would clearly identify the sender, if the public key isn't out there, then it would then be risky to send personal information.
We wouldn't do it that way. Right. If I was going to send you a private message just to you, I'd use your public key, and you'd use the private to decrypt it. Then nobody else could decrypt it. Okay? Okay? All right. So, okay, everything makes sense so far? Okay, so that's how you can have your transactions out on the blockchain in public view with others and still keep your privacy. Public private key encryption. Okay. So now, what about this thing about you can't change it once it's created? You can put it out there once and then it can't be changed. That doesn't really make sense if it's out in text, which it is. How does that work? That works because of a technology called hashing. Anybody know, guys, I talked about what hashing is. Everybody familiar with hashing? Ever used it for anything? Right? So a few, right? Hashing is used many times for passwords. It's not a recommended way to do this, but instead of putting clear text passwords in a database, you could hash the password when the user keys it in, put the hash in the database, and then always compare against the hash. That's why that when companies do that, they can't tell you what your password is because they don't know. There's a hash in there. So, but in the blockchain, they use this SHA-256. What does that mean? It is an algorithm that's used. The 256 are how many bits involved in the output, the hash value itself. And in here, it shows the bottom there, those string of characters is actually the hash value, the SHA-256 hash of the string of those 6 characters right there. Those 6 characters hash to that, which represents 32 bytes of data. Now it's printed so that each byte takes up 2 character spaces and so on, so there's 64 characters. But 6 characters always generates the same size hash. That's what hashing does, okay? And again, remember, the key to hashing and why it's important is that if you hash some data and you get a hash value from that, and then sometime down the road you look at the same data, at least you hope it's the same, you hash the value. If you compare the hash values, you'll know whether the data has changed or not. Because if the hash values are the same, the data is the same. And that's key in blockchain. So it's not actually that the block of this data can't be changed, and I'll show you more detail about that, but the fact that you would know immediately if someone ever changed it because the hash values are not the same. Things would change. I'll show you an example of this and how that works. But these hash values are really important, that even if the data is really close, like if I have all these characters, I change one little character in there, we want to make sure that the hash values are either not the same, but they're very not the same, if that makes a sense. So here's what it looks like. So what I direct your attention to the rows for TXT1 at the top, and then 2 down, TXT2. All the zeros in TXT1. And on line 3, TXT2 has all the same number of zeros except for the very center character is set to a 1. Hash 1 is the SHA-256 hash of all those zeros. That's what the hash value is. Hash 2 is the hash value for text 2 with the 1 character difference. Then the last 2 lines up there show you the 2 hash values side by side. And you'll notice the white letters or numbers in there are the only things that are the same. They're like 2 different things. That's why it's so simple for just checking the hash to see if anything has changed. If the hash values don't match, I know they're not the same data. And that's one of the things key in blockchain. The data that goes in these blocks are all hashed together. And again, more details in a bit. And so I can rehash the data, and if I don't come out with the same hash, I know something's wrong. And all of you will have a copy of it. So you may find out before I do that someone's hacked this particular block. Okay? Okay, and there are sites out there. If you can either go to these sites, put in some text, and you'll get the hash value. Right? It's a simple process. It happens very quickly. I got some statistics I'll show you about how these hashes are created in just a little bit. So one of the things important here is that to verify that the data hasn't changed, I could rehash the data anytime and compare it, the hash I get, against the hash in the block. The hash is stored with the data. If those don't match, I know something's wrong. Someone tried to hack. It's really easy to figure it out. Okay? Okay, so hashing is involved when these new blocks are created. So you heard the term Bitcoin mining? Yep. Anyone? Okay. What does that involve? Well, I said, really Bitcoin mining is more accurately depicted as mining blocks for Bitcoin. And there's mining the blocks is taking all these transactions, putting them all together, and some data like what's the date and time, what block number it is. And again, these will hopefully become even clearer. And then hashing that data and coming up with a hash value. That happens close to instantaneously. It's so fast. You get a hash value. Down here, this right here, I took right off the actual blockchain yesterday. That's a real hash coming off the blockchain. See anything different about that one from the ones you might have seen in the little example I got? What do you see about that one that looks kind of different all of a sudden? Something kind of unique.
Repetitive characters.
So, what's that?
Repetitive characters.
Yeah, which character happens to be repeated all the time? And what location is that character in? It's the beginning. Okay, so one of the things that makes the blockcoin, this block mining difficult, is they put some special rules on the hashes that come back. Like, not any hash will do. Only valid hashes are those that have a certain number of zeros at the beginning of the hash. So not anyone hash will work. You hash it. If it doesn't have the right number of zeros, it's not valid. Got to rehash. I said, So, and I'll tell you, but if the data is not changed, how would you get a different hash? Well, it turns out in the mining of these Bitcoin blocks, they add a number called, and I don't know why they did this, N-O-N-C-E, nonce. Nonce is just an integer. Starts at 0 and gets incremented every time a block is hashed, but doesn't generate a valid hash sign. And they just increment the nonce, add 1 to it, and rehash the data again. So this number is part of the data that gets hashed. Right? They keep incrementing. So say, well, okay, there are actually 18 zeros that start that number. That's a valid one. That's on the blockchain. You could find it yourself. Right? Now I can tell you, I got a nice machine I do work on here. It's great, but it is not nearly powerful enough to generate that number. Let me show you, I did some samplings to give you a feel for how hard it is to come up with these numbers. Okay, so this is a table that I actually have the application running on here. So after we're done, since the last session, if you want, I can show it to you. If we have time, which I'm not sure we will, but if we do, I'll show you the program. I'll run it for you if you like. But this difficulty is, that's what they call it. It says how many zeros have to be on the front of the hash before it's valid. And I set it at 4. Not 18, but 4. And ran it on my machine. And it took me, my machine, 133,000 hashes before I got one that had 4 zeros on the front. Did it 133,000 times. Now, on my machine, that didn't take hardly any time. Maybe a second. Didn't take long. I said, okay, what if it's 5 zeros? Well, it went up significantly. Like almost 4 million hashes were required to create that hash. Remember, that hash means it's valid. You got to do it that many times before you get a valid one. All right, 5. 5 zeros, 4 million times. 6 zeros, 13 million times. Okay, now it's starting to get noticeable on my machine. I have an i7, 7th gen, quad processor, all that. It runs pretty well. But I'm starting to see the time it takes. And hashing, do it yourself, it's really quick, but not when you got to do it 14 million times. And then I stopped after 7. At 7, it needed 167 million hashes before I found one that had 7 zeros. The hash I showed you before had 18 zeros on the front. I said, I don't think I'd live long enough for my machine to generate that hash. Now you could get lucky, but the likelihood is, because those are, you can see the progression, they are exponential. My machine could run till my grandson is grown, and it probably still wouldn't find that. There's so many it would have to do. So the companies or the organizations that really do this have buildings full of graphical processors. You may have had issues where people are buying up the graphical processors and the graphics cards are going up and all that stuff. That's because blockchain miners are grabbing up those high-powered graphics cards to do this. And they have buildings full of servers to do it. There's even talk about how much electricity they go through to do this stuff. So why does this mean anything? Well, if you have a rule that says the only valid hashes have 18 zeros on the front, all of our computing power that we have in this room is probably not enough to generate one of them in our lifetime. Okay? And the committees that run the blockchain and stuff, they fine-tune this difficulty, they call it, so that even the biggest, baddest, fastest miners take 10 minutes to create one of those. And they keep adjusting it. If somebody has some newfangled piece of equipment and they start doing it 9 minutes, they up the difficulty. So they keep it around 10 minutes. The biggest, baddest machines in the whole wide world. 10 minutes. It's hard to generate a real hash that works in the blockchain, which is one of the reasons why it's secure. Because it's hard to create one, but it's as simple as could be to verify it's correct. Any of us on any machine we got could verify a block has not been changed by rehashing the data, and you'll get the result right away. But creating it's a different story. It takes massive amounts of power to do it, computing power. Does that make sense to everyone? Because that's really a key issue, that why it's hard to do but easy to verify. Yes?
So that is how they keep it secure. And so when people were creating all of these on their home computers, they had just a lower difficulty?
Yeah. Yeah, and the problem, and I'll describe in just a second why none of those numbers 4 through 7 are even in the ballpark, because they're too easy to do. Right? The 18 is hard. Oh, sorry. Go ahead. Yes.
So all the blocks that are made as of now, they have a higher difficulty, and all the blocks they have some number of leading zeros or some other.
The more current hashes are more difficult than earlier hashes, but the earlier hashes were still really significant, right?
They were all leading zeros.
Well, that's what that difficulty means. You got to have a certain number of zeros on the front, and it's a little bit more detailed than that. But for our purposes here, you can just think of, you needed so many zeros on the front of the hash before it's even valid. So go out and look at the first block in the blockchain, which I'll show you what that is, and see how many it is. You have a question?
Yeah, so regarding the field, is this for blockchain in general or like a Bitcoin specific?
Well, the Bitcoin is the data inside the blocks. It's different if you go to Ethereum or some of the other cryptocurrencies. They have different rules, okay? But it's just the magnitude of those rules. Like Ethereum, I think it's 15 seconds to generate a block or something. It's a different magnitude, so. Okay, so what's this blockchain? What's the chain part about this? We get the block. Okay, so this is what the beginning of the blockchain would look something like in a simplified form. It starts off with block 0, which is called the Genesis block. Every blockchain, and there are plenty of them, starts off with the Genesis block, the one that starts the whole process. So each block has a block number. They're assigned serially. The hash for the block goes in there, and then you have data. And the data includes the data you want to record, but it also includes like the date and time stamp, and there's a few other items in there too, including, and it doesn't exist in the Genesis block, but if you look at block 1 next to it, you see there's a p hash. That is the hash value of the previous block. So if the Genesis block has a hash of 123, then 123 is in the previous hash value, which is part of the data that gets hashed with block 1. Okay, is that kind of clear? Kind of so on. But the hash value of block 0 is part of the data of block 1. And the hash value of block 1 is part of the data in block 2, and all the way down the blockchain. That's how it ties them together. The actual hashes from the previous block are in the data of the current block. Yeah. We'll go through the example to see what the hacking part. Well, what's the problem with hacking and how's that going to work? Okay. So everybody get this. So the blocks are chained together. How the hash makes sure the data that was hashed when it was created, we want to make sure it doesn't change because it's just text. But it's the hash on each block that makes sure, that identifies what data was there when it was created. And I'll show you what would have to happen if we as a group decide to go hack into the blockchain. Okay, so assume we have a small blockchain and we only have 3 blocks in there, and we decide to change the data in block 1. Well, the data in block 1 has a hash value. It was at 456. Now, anybody hashes it, if we change the data, they'll immediately tell the block's been hacked. I don't trust your work. My block has the right data in it, and it doesn't involve that X is in the data. So they know right away. So what would we want to do? Well, we'd want to make that block valid by rehashing to come up with a new hash value which meets all the difficulty. Okay, but the hash that we had, the 456, is embedded in block 2. So in order to change the hash of block 1, we got to go to block 2. After we rehash block 1, get the new hash value, then go to block 2 and change the previous hash, which changes the data. Now we have to rehash block 2. And we have to do that for every block following the one we want to change. Now, is that a big deal? Well, anybody know how many blocks there are on the Bitcoin blockchain at the moment? You didn't know that? I thought everybody knew that. It's 545,624. Okay, so on average, a new hash can be created by the biggest, baddest hardware on the planet in 10 minutes. It takes 10 minutes to do every single one. Okay, so let's say we're halfway through, and we're looking at, say, 270-some thousand blocks to go at 10 minutes apiece with the biggest, baddest hardware on the planet. to affect our change of that. Even if you could do that, which is completely impractical, all of us also have can have the complete blockchain, every single block on our system. And so if someone could change block 1 and you were going to work with them, and it says, it shows here right in block 1 that I'm the owner of that watch. And you pull up your blockchain and you look at block 1, it says, mine doesn't say that. You didn't change mine. They changed their own, but they didn't change yours. Talk to one of your friends as blockchain. What do you got for block 1? Nope, I don't have that person being the owner of that watch. How likely are you to interact and buy that watch? You'll know that there's an issue. And you can actually follow the blockchain all the way through from the beginning to the end. So can the blockchain be hacked? Technically, depends on your definition of hacked. You could say, yes, you can change the data. Can you get away with it? It's virtually impossible. It's out in the public, it's in text, but you can't change it without anybody knowing about it, which is how people get away with it right now. So the blocks would look, the chain would look something like this. My nefarious one might look at the top where the way the Bitcoin blockchain, you have like this in and out. And the in and out, you have the who, which is really your public-private key stuff, and then the what. What are you transacting? And so things in the in column, people have and are transacting to someone else, which is the out column. And this would tell you that on line 1 at the top, in both cases, Rolex didn't get it from somebody else, they created it. They created that watch. It tells, because on transaction 1 in both cases, we got an out, it says Rolex created the watch. Okay, in transaction 2 on both of our blockchains that we look at it, it says, okay, the Rolex company took the watch and sold it to Genesis. Now Genesis is the owner of the watch. And then in block 3, Genesis sells the watch to John Doe in both of our blockchains that we can see. And then finally we get to that I bought the watch from John Doe in that one, but in yours, which wasn't hacked, it actually was sold to Mary Smith. And you say, you don't own that watch. And I can prove it. Make sense? Okay, so things to remember about this blockchain. That is, it is a public. It's out in the public. It's immutable, meaning you can't change it. Once the blocks are created, you can't change them. It's distributed. We all have a copy of it. You can have every block in the blockchain, all 545,000 of them if you want. It's a ledger, so it's ins and outs of people transacting business, who you can't tell because they use public-private keys. It uses hashing. That's the technology that makes sure if somebody changes that data after the fact, we know it, like right now. And I tell you, any of our laptops here could run through 500,000 blocks in a couple of minutes and verify every single block in a blockchain. No problem at all. So one of the keys, though, is the difficulty in mining the blocks, of creating one of those hashes that actually maps appropriately based on the difficulty level, the 18 leading zeros. That's one of those fire and forget things, right? I don't know how long. I always wanted and had to mathematically calculate on my system based on my other ones how long it would actually take. I don't know. It'd be a big number, so. Okay, let me answer any questions you might have.